We all understand by now the importance of bringing AI to the edge. AI in the cloud is one thing, runs on big data center, infinite resources, you can do a lot of things with that. But if you want to guarantee your data privacy, latency in reaction to physical events, as well as ensure your devices, equipment, machines can be autonomous and don't need to ring a data center or be connected all the time to work, well, AI at the edge is the answer. There are tools to optimize AI and shrink it down to run on tinier devices. There are also some technologies on the hardware side of things that accelerate and make more powerful these existing microcontrollers. But there's a company out there that is pushing that a bit further. It's called FemtoAI. And Sam, the CEO of FemtoAI, is here to tell us about sparsity and how they were able to match how your brain works in terms of having neuron firing up or not in tech. Super interesting conversation today on how to make AI run on tiny, you'll see, like minuscule tiny devices, as well as the SDKs and all the offering that FemtoAI has to make AI at the edge simpler. That's today on the IoT Show. If you like this show, if you like this episode, do not forget to subscribe, talk about it to your friends, put a like, leave a comment. That really helps us producing more of these episodes. I hope you like that. Enjoy. Hey everyone, this is the IoT Show. Thanks for tuning in. My name is Olivier, I'm your host, and today we'll talk Edge AI, and more particularly, what is needed to make it happen. For that, we have Sam from FemtoAI. Sam, how are you?
I'm doing well. Thanks, Olivier.
So Sam, let's introduce yourself to the audience here. Who is Sam? What are you doing?
Yeah, so Sam Fok, co-founder and CEO of FemtoAI. We are in the business of bringing AI to physical layer, the goods out into the world. A bit about me. Stanford Electrical Engineering PhD, but sort of rewind from there. I am a Midwestern product. I grew up in a place where there's a lot of people, a lot of diversity around me, and I was always wondering, like, sort of why do we all think differently? In whatever way path I took in life, that took me down into engineering because it's really thinking about if you can make something, in this case human intelligence, then maybe you might understand something about it. So that got me interested in human brain, psychology, neuroscience, and ultimately electronics. Made that transition to say, like, okay, what can you learn or take from this existence proof in our head for general intelligence and apply it to electronics? And I think that's still an open question. So it's very interesting, but is also these days very commercially interesting.
Awesome. And we'll talk about that in depth, but Femto is a lot about optimizing for AI to run on tiny stuff, right? Femto means like 1 quadrillionth, so how do you come up with that name to start with?
Yeah, so the Jeopardy question is, how much energy does it take for one neuron's communication to bridge that synaptic gap and talk to another neuron, right? And the idea is that, if you can build electronics that work on the same order of magnitude of energy per operation, now you have the building block for, human level intelligence or biological level intelligence. I think what's more often said out in the world is that our brain is like 20 watts, right? And, you can compare however much power you think we're consuming in data centers to try to approximate it or try to add features that are beyond it. But this is looking from the other end. It's saying, like, ground up, maybe first principles is like, well, how much energy should it take to do an operation? And then from there, you can build architecture. You can do a little bit more of a forward engineering approach. So yeah, Femto, 10 to the minus 15.
Interesting.
That's about the amount of energy in terms of joules that it takes to talk between one neuron and another.
Fascinating. I didn't realize that. And that leads to my next question, which is, what we're seeing today, AI running in is big, huge data centers consuming a lot of energy. Everyone is freaking out about, the amount of energy it consumes, and everyone is talking about their AI consumption, almost like we were talking about carbon emission not long ago, right? Which we should talk about still. But anyways, why do you think it is that important, besides the energy consumption, to bring AI at the edge and to execute these machine learning models down there where the data is produced? Do you see that as a trend, and what are the use cases and scenarios for that?
Yeah, absolutely. I mean, the data center and the GPUs inside of them, of course, are very, very, very powerful. And so you can do a lot of stuff on there. That's very good for when you are in R&D mode. But once you are really deploying out into the world, and you have to worry about system architecture, like how do you get data back and forth to the thing that you're holding in your hand and the data center where the compute is, then there's a lot of challenges there. You mentioned a number of these things, right? So absolutely, power consumption is massive. Sort of as a species, we're kind of pushing some of the limits that we may or may not want to do. But economics is kind of driving it, or at least interest in this area is driving it. There are other challenges around, well, what happens if your internet drops? So, if our video stream here is shaky, like, yeah, imagine if you have this expert that you can always talk to, but you sometimes get an answer, but you can't reliably always get an answer, right? That's hard, right?
Yeah.
Especially when you're working with a real physical product that has to sort of just work. Like if I have if I have my car, right, I don't expect it to always have to ask the mothership, because what if it can't talk to the mothership, right? I still expect it to drive, right? So there's a lot of reasons: power, reliability, robustness, simpler system architecture, costs, right? Like if you don't have to essentially foot the bill on the server end, it can just be the battery or the wall outlet. There's a lot of reasons why you would want to push things out, intelligence out further into the world. Practically speaking, what we see is that a lot of systems end up with this hybrid architecture where maybe the biggest, heaviest, most complex workloads run in the data centers and the servers. But if, the things you're trying to do, or this product is trying to do, if you can handle like 99.5% of those tasks or workloads just right then and there, you maybe should do that, right? So from a product developer perspective, you want to provide a great experience. You want to have something that's very sophisticated, or at least does is very powerful. So you want that full scale power that you can access only in the data center. But if a lot of times you're just doing simple stuff, let's say like a simple voice control, like then you just do that out in the world. So yeah, there's some real sort of product robustness, reliability, economics reasons why people are pushing intelligence out into the world.
Yeah, and there's something that you guys are contributing to, which is the progress in hardware and software and tooling to make it possible, right? Because to start with, AI is something that is about billions of parameters, lots of memory to be used. And now we're talking about, oh, wait a second, we need to actually bring that down to a place where there are resource constraints, right? At the edge, you can have heavier devices, like in an autonomous car, you have some pretty hefty hardware handling the full self-driving of the car itself. But then when you think about smaller devices like earbuds or things that are wearable, you have way less resources, but you need the latest in terms of innovations when it comes to hardware. And we'll talk about the SPU that you guys have put together. And there is also the fact that you need a combination of hardware, software, and tools. It's not just about some hardware technology or some advanced in software. It's a combination of those. So tell me a bit more about these aspects of what it takes to bring AI to the edge in this context of today, and then we'll talk about the innovations you guys have been pushing pretty hard lately.
Yeah, it's a great set of questions. It's very big. It's just essentially, how do you make it happen? So I'm gonna tell you it's all of the above, right? We are just as much a hardware, like fabless silicon company, as well as a software company for software and tools, as well as an AI company building AI models that actually run across these things. So, and you need all of it, right? Like I don't see a near future where new company startups are going to be able to just say, I am a hardware company, right? Because you have to essentially meet your customer where they are, which is up at the feature level oftentimes. And that requires that full, very vertically integrated stack to ultimately deliver the compelling features. So that we can start at the ground level. So yes, we do design silicon as a fabless semiconductor company. So actually this is our little product here. So very, very tiny.
Very
It's called the
small, very
Sparse
small.
Processing
Hard to
Unit.
show the camera, actually. It's pretty hard to show here.
Yeah, it's there you go for scale, right? So like a quarter the size of a pinky fingernail is maybe if you want to check for yourself how big it is. But the idea is that it is called the Sparse Processing Unit because one of the core principles that it leverages is sparse math. So this is just the idea that a lot of the work that neural networks do is ultimately not necessary when you're deploying it, and so you can zero that out. That's the sparsity. But you need a sort of ground up rethink of the hardware, ICE instruction set, architecture to actually be able to deliver the benefits of that. So you need to have compression built in that needs to be realized on the silicon. But this in turn unlocks this sort of brain inspired optimization for models to the model developers, right? So that takes us up the stack, right? Because while this is a wonderful piece of little silicon here, it's just a grain of sand, right? You're not going to put it
Yeah.
into something and just expect it to, add wonderful magic without software and, features on top of it. So, yeah, we spend a lot of effort building out Toolchain. Basically, how do you meet the developer where they are? So your AI model developer, they have some kind of AI model feature, whether it's, cleaning up speech, whether it's, processing a little video stream for looking for something, or looking at audio stream for some kind of commands. This is all tooling that we've provided to help model developers, one, get their models just deployed very easily, but then two, unlock the sparsity as an optimization tool. So it's very easy. You just basically hook into your training loop some additional objective functions, some training schedules or pruning schedules, and then this will help you make your model as sparse as it can be while maintaining performance and get that deployed. That's not it. So that's for the developers. Then there's, of course, the people who are maybe integrating product electronics who are ultimately thinking about for us as end consumers, like when we go into your friendly neighborhood big box electronics retailer or local electronics retailer and you're buying stuff, there is some feature that you want in these products that will ultimately sell. So we have our own AI teams as well who build out some of these capabilities so that they're just ready to go for any of these OEMs or product developers to just incorporate into their systems. So at the end of the day, they might just be buying a feature. It just happens to be implemented with a really tall tech stack that goes all the way from AI models down to silicon. But ultimately, yeah, they just want some of these features to incorporate into their products that are now enabled by AI that maybe weren't in previous generations of signal processors.
Yeah, that makes sense. And we didn't mention that, but one of the biggest complexity in bringing AI to the edge is the fact that you have different type of backgrounds among the different engineers and people involved in projects, right? You have people coming from the world of embedded IoT, connectivity, AI itself, data science. And so providing as much as possible, definitely something that will help these customers who have a product but don't have the skill sets or the knowledge to do the rest, right?
Absolutely. Yeah. This is there are some wonderful parallels between ecology, biology, and sort of the diversity you see out in the world in terms of organisms growing or evolving and adapting to their environment, and the sort of what we see developers coming from. Like there's a let's be honest, like AI in many incarnations, if you take it, has been around since like 1950, right? So it's just how do you produce this human level intelligence? There's been many ways to do it. There's also many ways to process signals, and so our developers are coming from this long, rich history of disciplines, and they may or may not be so familiar with the more dominant paradigm today, which is backpropagation trained multi-layer neural networks, and of course that's since gone into these transformers, convolutional neural networks before them. But all these things are all still around, right? So people, wherever they started their journey or wherever they really did their professional career, that's often where they will be coming from. So you kind of need something to be a very easy on-ramp. You need to have materials, which we have in our developer portal, which can get people up to speed and running end-to-end as quickly as possible so that they can basically work at the higher level of what feature do I want to deliver here, and then how to build an AI model for it, if I need to, how to collect the data for that, and ultimately how to get that deployed. So yeah, huge range of folks that we're working with. Everybody from sort of the AI native students right out of school to sort of the seasoned maybe DSP veterans who have been living in sort of the idiosyncrasies of DSP developer environments their whole careers.
I want to go back to one thing that you skimmed over, because that's something that to me is really core to what you're doing, and it's like up on the site, and it's explained very simply actually on the site to a point where I understood. So can you tell me a bit more about this notion of sparsity, and illustrate how it makes this AI running on tinier devices that efficient, and that that much consuming less energy than traditional neural network would say?
Yeah, absolutely. If you recall your neural network sort of cartoon diagram, right? You just have layers connected to layers with layers of these very abstract neurons connected to each other, all to all. And then you contrast that with what you might actually see in an organism. Like if you zoomed, took a microscope and looked in very closely, you know that there's a lot of smaller structures. Not everything is connected to everything, right? And there's a very sort of rich field of kind of, well, what are the right model architectures? Sort of transformers are dominating today, and now we're doing all sorts of crazy things with them. But when you look at sort of what is actually happening in the real world with biological systems, you see that there's a lot of things that are not connected to each other, right? So there are a lot of places that have connections, a lot of places that are not. I think another really simple thing to understand is that it's like, okay, when you're born, you have a lot of neurons and connections in your brain, but as you grow older, a lot of those get pruned away, maybe through hard life experiences, but also for a reason, because there's limited real estate to use. It's not like your skull gets more empty. It really just prioritizes. It prioritizes the connections that matter, and then lets prunes away, or lets the withers away, the ones that don't. Right. So this is just the same idea applied to the algorithms and ultimately the electronics. Right. It's saying that hey, if this line of processing is not contributing to the end task, why am I doing it? Right. And that's really the contrast with what we see in a lot of processors right now who are thinking about AI, is that they basically take as their homework assignment, here is a matrix operation, do this matrix operation, without so much thought as to, did I need to do that whole matrix operation? So something that the field is pushing very hard on are sort of different number formats. So you're talking about like extreme, very low bit widths compared to what we had before, or new kinds of floating point or block floating point or shared exponents. This is fine. What we are more harping on is that maybe you didn't need to do any of that math or a lot of that math to begin with, right? So you can do that, and we do that. Then with the optimization of the number formats, but we also open up this new avenue of if you don't need to do an operation, just totally skip it, right? So back to the simple, platitude is just basically you're trying to work a little bit smarter rather than working harder, which is the brute force approach that we see a lot of these systems enable today.
Let me ask you the last question for you, Sam. So if people are interested, want to try things out, what is your recommendation for our viewers today?
Yeah, please check us out at femto.ai. And if you are either building a product or a developer for sort of AI capabilities and systems, we have a whole developer portal. So that's developer.femto.ai. Free to register. You can play around inside of there, see a little bit of developer ecosystem before you get too far into it. But yeah, it's all about how do you meet developers and customers where they are, which is you have a feature you want to implement, or you're a developer looking to bring AI into your products. So we try to make that as easy as possible. So please check us out there. You can, of course, also reach out to us, just hello@femto.ai. And we'd love to see as many people as they can kind of help collectively push AI features into the real world and these real physical goods that we use every day.
Awesome. Perfect, Sam. Thanks for your time today, everyone. Don't forget to go and check out and eventually reach out to Femto. And thanks for tuning in on the IoT Show. See you soon.
Great. Thank you.